Alright class, this is the second day of Unit 1. This is graph of a function. First of all, let's just remember that the domain is the set of all x values that make the function true. It's also, if you want to think about it, your input. Range, again, are the outputs or the y values that make the function true. So the output, we talked about that yesterday. Interval notation. Okay, so interval notation, we're going to just look down here at this example. I'm going to call this interval A, this interval B, and this interval C. When you're doing interval notation, we're looking at only the x values only, okay? So, first off, whenever we use infinity or negative infinity, we have to use, okay, I forgot where I was, I got interrupted. I think I was saying that when you're dealing with infinity, you always have just a less than or greater than symbol because we can never equal infinity. And then there's two things you need to know for interval notation. If you have a greater than or less than sign, it's a parentheses. If you have a greater than or equal to, it's a bracket. So for this problem, we would say that the x's start from negative infinity and go up to 0 and include 0. That would be interval notation for interval A. Interval B, we're going to say we want it to only start at 0. Again, these are all x values. These are the x values from left to right. So I want to start at 0 and go to 5. Notice how both of those are parentheses because they are not equal. Here I want it to start at 5 and equal 5, so now we're going to have a bracket because of this symbol, and I'm going to say 5 to infinity. And again, infinities always have parentheses. Alright, now we're going to go down here, and it says find the domain and range, and then write the answer in interval notation. So first for domain. Domain is what are the x values. So here's an x, that's negative 4. And it goes all the way to 4. But it doesn't equal 4. Because it's an open circle. That's a closed circle. So I would say the domain here starts at negative 4 and includes it because it's filled in, so it equals 4, negative 4. And I have all the x values all the way to the right until we hit 4. And again, we're not including that because it is not a closed dot. The range, you have to look at the top and the bottom. So here's the top. That's a 4 up here. The lowest point this gets is negative 3. And since it includes both of those and every point in between, even though that's open, here it's covered here, so you don't have to worry about it. I would say the range for this is, and you always go from lowest to highest for range, negative 3 to 4. And remember the ranges and y's. So that's how you do interval notation. This we did on our packet. X-intercept is when the point crosses the x-axis, and to find it, all you need to do, well, first of all, so it's going to be a point that's x comma 0. And to find it, you set y equal to 0 and solve for x. So if I set y equal to 0 for this one, let's do that. I'm going to say 0 is equal to x minus 3 over x minus 1. Now this is where you guys have to remember what makes a fraction 0 when the top is 0. So we have to set the top equal to 0, and we get that x equals 3. So when x equals 3, the fraction becomes 0. We do not set the bottom equal to 0 because that's when we're looking for our domain restrictions, but that's not what I asked here. So the intercept would be 3 comma 0 for this problem. The y-intercept is the opposite. It's in the form 0 for x and y for the y. And to find it, you make x is 0. So when I make my x is 0, I get 0 minus 3 over 0 minus 1, which is negative 3 over negative 1. Which is just 3, which means that the coordinate of the y-intercept is 0 comma 3. So that is the x and y intercepts. Is the point 6, 2 on the graph? When I give you a point and you want to know if that point is on this graph, you just plug in the 6 for x and 2 for y to see if it matches. So 2 is the y equals 6 minus 3 over 6 minus 1. Well, it does 2 equal 3 over, what is that, 6 minus 1 is 5. These do not equal, so the point is not on the graph. Not on graph. Because of this is not a true statement. Now, this is very important. A lot of people mess this up. It says if f of x equals -1, what is x? So I do not know what x is, but I know my function is -1. You have to think of this as your y. So y equals -1. So if I say -1 is y, I want to know what x value is on that graph. Hopefully you guys remember this from geometry. When you have a fraction equal to a fraction, I can just put that over 1, you can cross multiply. So when you cross multiply here, you get x minus 3 equals -x plus 1. And now you can solve. Move the x over, we get 2x plus 3 equals 4, so x equals 2. So yes, and if x equals 2, then the point has to be 2 comma -1, because you should already know that you're going to get -1 out, but you could check it if you want. Okay? So again, that's your y. Set y equal to the function and solve for x. Alright, so now we're doing function notation again. So it says for this graph, find f of 3. So that's saying what is the value when x is 3, that little x. Okay, so here's x is 3. What's the value of the function? This is -3. I look for when x is 0. When x is 0, I have a 2. And when x is -4, I have a 0. So those are my values. Now this is the opposite. This is saying when is the y equal to 0? Alright, well, there's two spots where the y is equal to 0 if you look at the points. It's when x is equal to -4 and when x is equal to 2. When is y, remember the function, greater than 0? So they're basically asking you when are the y values bigger than 0? So wouldn't you guys agree it's between these two x values? So I'm going to write that in interval notation, but I'll write it both ways. So if I use the inequality, I would say it's greater when x is between -4 and 2. Or you could have written it in interval notation, which we talked about on the first page. And since it's not equal to 0, we don't want to include those values because they're equal there. What is the domain? Well, we talked about this on the last page. It starts at an x of -5 and it goes to an x of 3. So again, you can do -5 is less than or equal to x, which is less than or equal to 3. Or with our new notation, we can use it. We could just say it's -5 to 3 with brackets because it's domain, it's what's included. Okay, so now we have to look at the y's for range, and the lowest y is actually -3. I know this graph is not really drawn to scale. -3 is the lowest y, 2 is the highest y. So for the range, we would say we go from -3. Be careful here, you can call this y, or you could say it's -3 to 2. The x-intercepts are y is 0, so the x-intercepts are -4, 0. And 2, 0. The y-intercept is where it crosses the y-axis, so that would be 0, 2. It says when is the function equal to 2? We just found that actually. If you notice, the function is equal to 2 when x is equal to 0. When is the function equal to -3? It's right here actually, when x is equal to 3. Okay. So that is how you can read these graphs and go through them. Again, if I went too fast for you, you can always rewind and listen again. This down here is just another quick example. If you want, try to pause your video before you go on if you want to try it. So first off, is this graph a function? And we would hopefully say yes, because it passes, if you guys remember, the vertical line test. So to do that, you just draw a couple vertical lines, and it has to only hit once. The domain goes from -7 to 7, so I'm going to just use interval notation now. If you want to use your inequalities, that's fine too. The range goes from 0 up to, it looks like 4, and includes both of those. What kind of symmetry? It's folded over the y-axis. Later on, we're going to call this even symmetry, so I'm going to just put that there, but you do not need to know that for right now. Okay? All right, so that is day 2 of functions.